Hi, and welcome to the next module of the course, which is about deep learning for NLP. In this module, we will learn about what is deep learning, why we are exploring this field of deep learning. Then, we will discuss what are some of the applications of deep learning with NLP, and finally, we will implement text classification using deep learning. So let's discuss what is deep learning. Deep learning is essentially a subfield of machine learning which is primarily concerned with algorithms that are related with structure and functioning of human brains. These models belong to neural network families, but unlike simple models, deep learning models are comprised of many layers which are stacked together one after the other, and these layers represent some complex functions. What are some other differences of deep learning models and machine learning models? The focus of machine learning models can be broken down into two components. First component represents the input data as a set of features, and the second component represents a machine learning algorithm which is applied on those features that will find most optimal weights and parameters. Additionally, it is the role of humans or say data scientists to describe that given data as a set of features. However, in deep learning, model architectures are designed in a manner to automatically learn the best features and data representations. Deep learning models have the capabilities to learn more deeper features from the data and learn their multiple representations. And finally, they can be ran similar to machine learning algorithms in order to optimize the parameters and feature weights. So why are we exploring the field of deep learning? First of all, in the past few years, we have got access to massive amounts of data. With the availability of more and more data, the classification and regression models can be trained more effectively and with higher accuracies. Secondly, we have also got access to large computational power, due to which many complex models can be trained effectively in a less number of hours. The advent of GPUs and TPUs have improved the computational training time as well. These are mainly the two reasons that deep learning has become popular in recent years. But apart from the availability, there are some other advantages which machine learning models cannot provide. With deep learning models, low level or a deeper level features from the data can be recognized, which is not with the case of simple machine learning models. For example, in the face recognition problem, a deep learning model will automatically identify the nose, ears, etc. But a machine learning model will have to be provided with humanly created features. Also, these features are highly informative, which is helpful for classification and regression tasks. Moreover, deep learning also enables transfer learning, which essentially means that the trained models on a dataset can be transferred to other datasets as such. And finally, recent years have seen many success stories of deep learning in almost all the sectors such as manufacturing, healthcare, finance, etc. NLP is no different. Let's look at some of the deep learning applications for NLP. Deep learning for NLP has helped in improving the current approaches to different natural language processing problems. Many organizations are now able to solve machine translation systems, text summarization problems, question answering systems using deep learning models. Many researchers have came up with sophisticated deep learning models which can improve text classification accuracies as well. Apart from this, language modeling, which includes examples such as automatic image captioning or automatic replies to emails and messages, can also be developed using deep learning. So why does deep learning models work with NLP? The problem with machine learning models is that the context is not captured, which means that any machine learning model will not take care of left or the right word of a given sentence while learning a pattern. So for example, in the two sentences, he was good and he was not good, the feature good will be treated individually. However, if we look at the second sentence, not good is an important context which will be missed in the machine learning model. Additionally, the training process of machine learning models Models will not capture what they have learned so far. Without the training history, the repetitive information in the documents will be treated individually, which will lead to more complex models. Deep learning for NLP architectures aims to improve these issues. Two of the most popular deep learning architectures are convolutional neural networks and recurrent neural networks. These models architectures are designed to learn the context from the text documents as well as maintain the history of training or maintain what has been learned so far. In these architectures, the input text is represented in a dense vector notation which is then fed into series of layers with subtle features. Let's look at these architectures in some more detail. In convolutional neural networks, there is an important concept of convolution. Convolution are essentially a matrix which contain parameters which will be learned or improved during the training process. These are also called filters. These filters are used to extract the features from the input text data. And these filters are applied in a sliding window manner where the filters move over the input words and their neighboring words in order to generate new features. For example, in the given image, if the input text is represented in a form of a matrix and the red box represent a filter, after the filter will move in a sliding window fashion over all the pixels and it will multiply with the weights present in the filter, some new convolved features will be generated. So convolution can give a variety of features from a given input data. If one can use different types of filters on input data, then different types of features can be generated. For example, consider a sentence. I like movies very much. In this example, one filter may detect like is a positive word and is not a similarity comparison. Other filter may recognize that context of bigrams such as very much is used as an expression or an intensifier. The flow of a convolutional neural network architecture for text classification is described as a given input is passed to embeddings. Embeddings are then passed to convolutions, which are then passed to pooling, and finally they are passed to softmax. Let's understand these terms in detail. The input data is first represented as word embedding notations, which is then used to pass information to the other layers of the convolutional neural network. Input is generally a corpus, which essentially means a set of documents or sentences. Now, embedding represents word vector notations, which can be computed using pre-trained word vector models such as fast text, word to vector, or globe, where some convolution units are added and the convolutional filters move over the input embeddings to generate new features. Pooling layer is used to generate most informative features from the convolution features. And finally, softmax layer is then used to perform classification, which essentially maps the learned features into given categories. Also notice that in the embedding representations, we are essentially passing documents, but we converted words into their vector notations. So to generate the vector notations for documents, one of the idea is to average over word vectors or use weighted average using TF-IDF of every word as their weight. Now, convolutional neural networks for text classification can be implemented using Keras libraries. So, to implement them, we first need to import layers and models from Keras libraries. We can define our first layer as input layers, and we can pass the size of our input, like how many number of words or how many number of word, what is the size of word embedding which will be passed into input layer. This input layer is then passed into embedding layer where new embeddings for these keywords are learned. And inside this we pass our vocabulary size, which represents total number of words present in the corpus, and a fixed embedding size, say 100 or 200, that we want to obtain. The embedding layer represents the learned word vector notations which are then passed to convolutional layers. Inside the convolutional layers, we can define number of convolutional units. In this case, we have defined 100 convolutional units and we have defined a filter of 3 with an activation function of ReLU. We can use different activation functions as well, such as sigmoid or tanh. The convolution layer is then passed to pooling layer where max pooling is performed, and the role of max pooling is to generate most informative feature or the maximum value from the convolution layer as such. This is then passed to output layer where a simple dense neural network can be used and the number of categories or number of dense units can be applied. In this case, there is first dense unit in which 50 units are applied. Then the output of that dense layer is passed to another dense layer with just a single node with sigmoid activation, which essentially represents a classification task. And in the end, the final model can be compiled as model containing input as input layer and outputs as output layer too. Thank you.